So my presentation will summarize the experience what we gained during implementation of regulatory approach in AERB. Somewhere in 2018, we started this work. We took about 1.5 years to develop the document. In almost all the facets of regulation, in all regulatory processes, sub-processes, inputs, outputs. So the presentation will start with a brief introduction of graded approach, why we need it, what it is, and where it needs to be applied. This will be followed by the main part of my presentation, which is based on our experience on implementation of graded approach. That is how it should be applied. So it will cover basic concept for implementation, identification of control elements in each regulatory process, then identification of influencing factors and how to integrate control elements with the influencing factors so as to apply graded approach in regulation. And then in AERB, through what documentation we have implemented it, and with a small case study. Then what benefits one can derive from, a regulator can derive from application of graded approach. In fact, graded approach is a single shop solution, and it brings many goods to the regulator. In fact, if I say it is a lucky charm for regulator, because it brings many benefits to the regulator. So a brief introduction about graded approach. Since regulatory body deals with a wide range of facilities, right from X-ray to nuclear power plants, and these facilities pose different level of radiological risk. Due to this different level of radiological risk and many other influencing factors, we need to apply graded approach during regulation so as to ultimately achieve a required degree of controls as well as to rationalize our regulatory efforts. IAEA safety standards, right from safety fundamental principles to down the line general safety requirements and guides, invariably every document talks about application of graded approach in regulation. And fundamental principles from where this quotes is taken, it gives some overarching requirements, some idea about how graded approach should be implemented. So it states that scope and stringency of regulations and their application should commensurate with the magnitude of radiological risk and their amenability to control. And regulatory controls may not be needed where this is not warranted by the magnitude of radiation risk. So basically when we took our task somewhere in 2018, at that time no detailed guidance documents how graded approach should be implemented in regulation was available. So we took these statements as our benchmark for carrying out our job. So with our experience, we can say graded approach is a structured approach. In fact, before 2018 or 17, we used to think a wise man can take some intelligent decision whenever needed during regulation, and that is graded approach. And it is a common sense, but now it is not that for us. In fact, many wise men should sit beforehand in the peacetime, should put their intelligence into a document and made available to complete regulatory body staff for its consistent application. Because with application of graded approach, the challenge is we are supposed to deal with a large number of facilities. And for each of these facilities, we do minimum 5 core regulatory processes and many sub-processes as well. And then there is a regulatory staff who is actually going to conduct these processes. So there are many vulnerabilities or challenges towards application of graded approach. Until unless it is implemented in a guidance document, it cannot be effectively and consistently applied. So graded approach, it enables regulatory body to decide where or whether regulatory controls are warranted in a particular case or not. If controls are warranted, then what should be the scope, nature, degree or depth of regulatory controls? And graded approach needs to be applied in regulatory framework, like from the legal to and regulatory framework, then to regulatory functions, processes, and management systems as well. So the first and foremost thing is where regulatory controls are warranted and where not. So as a regulator, we deal with both artificial as well as natural radioactive sources. Certain sources, even though these are required to be controlled, but they are not able to control. So they can be put out of regulatory net as stated by IAEA safety fundamental document as well. So we can exclude them out of regulatory net. Then in some cases, it may happen that these sources, they don't pose that much risk that we should pay regulatory attention for that. Such things can be exempted or cleared from regulatory control after some time. So what I mean to say is, for application of graded approach, a regulator needs to fully exploit the concepts of exclusion, exemption, and clearance, so that it should be pretty clear to its regulatory staff where regulatory controls are not needed and where regulatory controls are needed. The set which will be other than that, set of facilities and activities, these must be regulated through a regulatory framework and warrants regulatory control. Now, the facilities and activities which fall under regulatory net, these are generally controlled by a regulator through development of safety regulations, then by implementing them through licensing process and safety review and assessment process, verifying them through inspection process, and if at all there is a case of non-compliance, then enforcement is the process which is performed by the regulatory body. So the facilities which needs to be regulated, for application of graded approach for these facilities, graded approach needs to be applied in the regulatory processes of these facilities. Not only the regulatory processes, but in regulatory sub-processes as well. Like in safety review and assessment process, mainly it is done at the licensing stage and during relicensing stage, but there are many other processes like review of events, review of modifications, though they are basically the part of safety review and core process, review and assessment process. Even in those processes, graded approach needs to be applied. And it is not only restricted only up to the process and sub-process level, but it needs to be applied for inputs as well as for outputs. For example, for licensing of a complex facility like NPPs, submissions which are required for safety justification to the regulator may be many. So by applying graded approach, regulator has to prescribe in its regulation what kind of submissions they demand for a licensing of a facility A, B, or C. Similarly, in the output also, graded approach needs to be applied. The example is regulatory inspection is a process, but its outcome is observations. So we have to categorize observations also based on their safety significance so that we can pursue it according to their significance in a right manner. During safety review and assessment process, there could be recommendations, there could be action items. So regulator should have a guiding tool to determine safety significance of these action items so that they can be followed up later on by the regulatory body staff in a graded manner. So what I mean to say, graded approach is not only limited to processes, it also extends to sub-processes, inputs and outputs. So it's a big gamut. In fact, applying graded approach in any of the domains, whether input, process, sub-process or output, it itself is a subject in it that I'll show you through a case study. Now, coming to the basic concept for implementation of graded approach. For implementing a graded approach, a regulator initially should identify the process wherein it wants to apply. Then within that process, regulator job is to identify the elements of control. We say it as a control elements. Like for a regulatory inspection, one of the control elements could be inspection frequency. And like that, for every process, there can be some 5, 6, or even 10 number of control elements. Once control elements are identified by the regulator, the next job is to identify the influencing factors. Factors which may influence this control elements. For example, inspection frequency may depend upon a potential risk. For NPP system, for facility like NPP, which has a high hazard potential radiological risk, inspection frequency may be stringent. But for X-ray and all, it may be on sample basis. So through one example, I've tried to explain what is basically the graded approach up to the implementation level. So finally, once control elements are decided for all regulatory processes, as well as influencing levels are decided, then the regulator job is to integrate these two. There could be multiple influencing factor for a single control element, and he has to finally decide the scope, nature, and degree of controls. So here are few examples of control elements for few core processes: licensing and regulatory inspection. For regulatory inspection, type of inspection, regulatory body in its kit should have all kind of inspections, like plant inspections, wherein a kind of skimming is done, like a top level skimming is done to see various areas, but without going into deep. We say it as a horizontal skimming. In case of a special inspection, we can do a vertical deep diving inspection in a particular area for a particular system or in a thematic area. Then another control element could be periodic or sample. For all facilities, it may not be in the same fashion. Even there could be periodic for many, but frequency may change. Then frequency of inspection, what should be the scope and depth, team sizing, composition, inspection method, and even for the outcomes, as I said earlier, graded approach is required. These are the control elements which we need to control. For licensing process, the control elements are format and content of the application which applicant has to give for justifying the safety case. What should be the lead time for the application? In what licensing process should be done? For a facility like NPP, which is a complex, stages may be many. For other facilities, it may be limited, or based on experience, even for a repeat kind of NPP, because repeat is another influencing factor. Even for a NPP, we can club the stages for a repeat design or something. So those kind of flexibility needs to be instituted in the graded approach. Then type of instrument, even what kind of tag or license we are going to give to the utility, those names also vary. It is commanded by a graded approach, like license for a nuclear power plant or facility, but registration for an X-ray. Then licensing condition. In control element, there are some technical factors and there are some administrative things, like authority for issuance. Who will issue the license within the regulatory body? What will be the validity? What will be the review level? Whether stakeholders will be involved or not. So in control elements, few are technical factors and few are administrative factors. Technical factors will command a guiding tool for the regulatory staff so that he could gauge its significance. But administrative factor will demand a hierarchy in the regulatory body so that you can take it to the appropriate level. So after determining control elements, the next job for a regulator is to determine influencing factors. There are two prime influencing factors for application of graded approach. One is potential radiological risk associated with the facility. For this purpose, in AERB, we have categorized facilities into 3 grades based on their consequences, maximum possible consequences in offsite domain, onsite domain, and further in offsite domain, whether they can lead to severe deterministic effect or deterministic effect. Similarly, in onsite domain, whether they can lead to severe deterministic effects or on-site deterministic effects. This categorization takes care of all kind of facilities and activities, even sources, and also accounts for IAEA categorization of A/D ratios for radiation sources. Here, one thing I would like to point out that whenever we are evaluating potential consequences, means we are not taking credit of any of the safety systems. This is the maximum potential damage it can do. You can say it is a bare risk, but we are taking credit of the physical and chemical mechanisms. Like, for example, a nuclear power plant has some radionuclides, some level of activity. If same level of activity I can put in a tank in liquid form, but the consequences will be same. Here in nuclear power plant, some energetic reactions can take place, which can catapult complete activity into the environment. It can go far away. But if it is in a liquid form in a tank, consequences will not be the same. So what I mean to say, we are not accounting any safety system credit, but we are taking into account all possible chemical and physical mechanisms while evaluating the potential radiological consequences and categorizing them based on that. Next, influencing factors. Potential risk means, which I explained earlier, it is maximum, it can do this much, a particular facility. And for all the facilities, it will vary. Now, coming to the acceptable risk. Acceptable risk is nothing but it is our dose criteria. Now, this in turn depends upon an exposure situation. For a plant exposure situation, dose criteria will be different. In emergency and existing exposure situation, the dose criteria will be different. We will not say further it as dose limits or constraints. We say it as reference levels. So acceptance criteria is the landing point. Regulator has to see what controls needs, safety systems needs to be instituted so that facility becomes acceptable to a regulator or to the public. So this in turn depends upon, first of all, nature of exposure, then practicability of reducing exposure, whether you are able to reduce it or not. Socioeconomic factors, this especially plays a role whenever we are deciding reference level for existing exposure situation or emergency exposure situations. Thus, some national and regional factors also play a role. Then, of course, international guidance, which is available, is always accounted. For plant exposure situations, generally dose limits and constraints are defined. These are very restrictive. And if at all there is a deviation from that, it constitutes a regulatory violation. But for emergency and existing exposure situation, reference levels are defined. These are a kind of benchmarking which utility has to follow. Benchmarking for them so that exposure beyond that above is ideally not desirable and it should be optimized under that only. So there are few other influencing factors other than prime ones, that is potential risk and acceptable risk. These we say it as generic factors and specific factors. Generic factors, these factors, influencing factors, are invariably applicable to all processes like design, new or repeat, what is the stage of facility, complexity, maturity, age of facility, safety performance in past, competence of manpower. Like if I want to do regulatory inspection during under construction stage of a facility, so my frequency may be different, my scope area may be different. But when I'm doing it when it is operating, frequency may be different, even scope area may be different. So these generic factors are basically invariably applicable for all processes. But specific factors are applicable only for specific processes. Like for example, if I have 10 modifications proposals on my table, so significance of the modification will drive which one I should take first for review, which one I can delay a bit. Similarly for events. So these are specific factors. Now, this is the pretty hard task actually. Once regulator has determined all potential, all influencing factors, potential risk, acceptable risk, generic factors associated with the process, specific factors associated with the process, his job is to integrate it and grade the control elements in terms of their scope, nature, and degree or depth. Primarily, or prima facie, it has been seen, controls are more whenever risk associated with the facility is more. and complexity is higher. So in AERB, we have implemented graded approach and we have documents for that, because there is a significance for having documentation. As I said earlier, many things are involved, number of facilities, the number of processes, then individuals are involved, because ultimately those who are going to perform the process. So if we want that our process should be in a graded manner, it should be well documented. So our level 1 document, IMS document, it mandates that graded approach should be applied in all our processes. Level 2 is the document which was developed by our team in AERB. This document defines everything, right from, it exploits basically that exclusion, exemption and clearance principle, where controls needs to be applied, where need not to be applied, where control needs to be applied. Then for each of the regulatory process, starting from development of regulations to licensing process, safety review and assessment, then inspections, and then enforcement. For each of the processes, it identifies control elements as well as their influencing factors. We have not even limited up to the processes, we have gone even up to the sub-processes as well as to their outcomes. So this is the level 2 document. It's a kind of Bible document for our staff for application of graded approach, and then integration of control elements with the influencing factors. That has been done by different divisions of AERB in their own divisional documents, which we say it as a level 3 documents. Like for review of modification, there is a level 3 procedure with each of division. So they are supposed to integrate all control elements and influencing factor in level 3 document for their regulatory staff. So this is an overview of implementation of graded approach in AERB. This is in nutshell is what I had said so far. So a regulator deals with natural as well as artificial sources. Green part is which is out of a regulatory net, and once these guidelines is available, regulatory staff can decide what needs to be exempted and excluded. But this green part is actually not rationalize the work of a regulator, because regulatory body staff in day-to-day business is involved in its process, carrying out its processes. So the major chunk where graded approach needs to be applied is for the facilities and activities where regulatory processes are actually carried out or which are under regulatory net. So there are the situations showing potential risk. We are supposed to land here if you want that facility should be accepted by the regulator as well as public. So in between there is a regulator with its graded approach, and they are supposed to decide in each of the processes how much scope and stringency of control they need to apply, considering prime factors and other influencing factors. Here I have specifically taken a case study because I said just now integration of control elements with influencing factor is a deep diving task and really requires a understanding of the process. So in facilities we perform modifications. Modifications are generally performed to drive some benefit. It could be also like we want to come out from a fault, like pressure tube, there was a leak, we want to segregate from the rest of the PST system. That is also a benefit. So generally in facilities, modifications are carried out to drive some benefit. But since we are introducing a change in a licensed system, means it's a safe system, so this change has potential safety implications. So as a regulator, when we are doing regulatory review of a safety modification proposals, we are bound to see two things: whether this modification is going to give intended benefit or not. Second thing, this change which is being introduced in the system, what could be the potential implication in different domains, and whether that has been addressed appropriately or not. I would like to tell you through an example. Suppose following a pressure tube leak, utility wants to remove the affected pressure tube. So this will require cutting of a pressure tube. It needs to be taken out in a shielding flask. Now, potential safety implications are radiological risk, dose to the workers, design of the shielding flask should be appropriate. When PT is being cut, whether a tool can cut CT or not, moderator may come out, it may have tritium. So what I mean to say through these examples, whenever safety modification is to be reviewed, two aspects are seen. It should be able to give its intended safety benefit. And second thing, regulator should be intelligent enough to gauge what could be the potential safety implications in different domains. And another job is to see all these potential safety implications have been adequately addressed by the utility, then only the proposal can be accepted for execution. So for this particular regulatory activity, we have identified certain control elements. Many a times we get generic proposals. We don't want to deal with separately for each plant, because now our plant designs, they are like same vintage plants we have. Dealing with separately with them means it's a burden on regulatory resources. So we have identified control elements like type of modification, category of modifications, scope and depth of review level, who will be the approving authority for the modification, timeline for review. I want to review it right away, it is so important, or I can take some time because we are burdened with anyway utility submissions for review and all. Then follow-up actions. If modification is implemented, do I want just a response from the utility, it has been implemented, commissioning results were fine, or I want that my staff should be present when modification. My staff should be present when modification is being implemented, or during regulatory inspection I can check. So there can be many things. So these are the control elements, and these control elements are influenced primarily by safety significance of the modification. And there are many upgrading and downgrading factors, and if it is a new or repeat, they want to do a single or en masse, like if SP&D they want to change in a power plant. Should I give a en masse replacement in RPS or not? Simple, complex, stage, potential for error during implementation. So these are the influencing factors. So taking into account what intended benefit it can give, because that also defines significance of the modification. And what could be the potential problems? If there could be a higher level problem, means significance will be higher. So taking into account these two things and the system wherein this modification is being carried out, whether it is a PST system, RPS, or some tertiary cooling loop, taking these things into account, we have categorized the modification into various types. And here are and color code for all our process outcomes, we have kept same, red, orange, gray, white. So this anyway I have told that regulator job is to define, he should be intelligent enough to decide what is the scope of a modification, in which domain impacts can be there, then in which domain they want a deep diving. We may go up to the expert committees for review, like for coolant channel matters we go there, for INC matters we go to SSAI. Then once categorization is decided, then whatever management has provided us the hierarchy, accordingly level of reviews and approving authorities are defined. Review priority, whether I should review it right now or later, even those things we have done. Now the last slide. So graded approach, as I said earlier, it is a lucky charm for regulators. It brings many goods to a regulator. First of all, what we have seen is there is a paradigm shift in the approach of regulatory staff towards dealing with regulatory activities. Now safety significance has become a paramount for doing any regulatory activity. During the course of implementation of graded approach, we have developed multiple tools for gauging the safety significance. If today I have some 10 events on my table, reports on my table, I have a tool to gauge which event is of more significance. For modifications, significance gauging, we have a tool. For regulatory action items, we have a tool. For RI findings, we have a tool. So we have many tools for determining safety significance of our activities. And with implementation of regulatory approach, now our processes are consistent and coherent. Volatility has gone, ambiguity has gone. Because of that, utility also knows beforehand in what way his proposal will be subjected to, or what level of review it will be subjected to. Definitely, by doing all this, we are doing our processes in a risk-informed manner, whether it is review or decision making. Our regulatory process, it has become effective and efficient. We are able to utilize our resources in an effective manner, and we are ready for future technologies as well. In the sense, because for example, whatever categorization we have made based on potential risk, it has not been done only for the facilities which we are dealing with right now. It is a guidance for categorizing any forthcoming facility which will come to our regulatory net later in the future. So thanks a lot. This was from my side, and I will give special acknowledgement to Shri D.K. Shukla, Chairman AERB. Actually, when this work was taken somewhere in 2018, he was ED at that time. He entrusted me and my team with the responsibility to perform the assignment of implementation of graded approach in AERB. Then second is AERB task force. Few of the members, I could meet them. Pimple, he is here today, and many others. They did really hard work for developing the guidance document for our regulatory body staff. And last but not the least, thanks to Shri Amit Kumar and Nitin Malik, who are my colleagues, and they really collated all the information and put them in perspective for this presentation. Thank you so much. Thanks.